Thank you for inviting me to Aalto University Summer School. My name is Magnus Frodig. I'm head of Ericsson Research, and I'm happy to address you all here from the Ericsson studio in Kista, Stockholm. The title of the talk today is on the 5G and 6G and how that could be an enabler for a green acceleration. I think we all know that we have a significant challenge ahead of us. We really need to find things that could get us going, and it's important then to try to start with the technologies and the fields where we are ready to apply technology already today. This slide shows how we need to reduce our CO2 emissions. And in order to meet the targets, we will have an important target to halve the emissions by 2030. And of course, the earlier we can get started, then we have more time to reach the halving by 2030. And the more we wait, the more urgent it will be, of course. So this coming 10 years would be extremely important. And this is really the decade where the 5G will be rolled out. And so we will have a gradually more and more sort of connected possibility, enabling technology, and that could drive this exponential change that we need to make sure that we get going forward. And in order to analyze this, we have been working very actively on this exponential roadmap 2030. This is a report that was first presented in San Francisco 2018 and an updated version in New York Summit 2019. So look a little bit more into the details of that report.
Good afternoon.
We can here look at the different sectors.
And welcome to the session of 5G and smart cities. Today I'm talking about the state-of-art understanding about the smart city services and data ecosystems development and in relation of 5G development. I want to actually to highlight that we need in everything that we do a little bit joy, a little bit imagination, and a little bit also that we need to go out of the box. And today we go out of the box, and I will actually talk more about the cities, future of cities, and different dimensions than technological dimensions. I'm talking about the business dimension, legal dimensions, social dimensions, and so forth, because those are as important as technological dimensions in reality when we are then commercializing and scaling it up, the technologies. I want to highlight that today 70% of the Europeans live already in the cities, and 56% of the global people. Now the estimations by the United Nations and OECD says that 20 to 50, 70% of the global population will live in the cities. So cities are the very important now, but they are even more important in the future, and also in the technological developments. In addition, the cities are the main source for global emissions. And today, 76% of the global energy use and carbon emissions are done by cities. And of course, the key contributions are the buildings and transport. And of course, the key issues is today is the people, quality of life, climate, and connectivity. And in the connectivity related to these issues, we need more connectivity and capacity, and that will increase with the 5G and with the higher frequencies. And we need the denser networks as well to face the challenges that we are facing today. And of course, if discussing smart cities, in international benchmarking, there is smart cities all over the world. A couple of examples: Toronto, where the Google has been actually, very influential. Paris, Issy-les-Moulineaux has been a smart city for a long time. We have nearly in every cities smart city developments. A couple of mentioning Helsinki, Espoo, here in Nordics, Brussels, and Lyon, and so forth. So we can say that in every city we can find out the smart city developments related to different topics. So thinking about if going further to the future of the cities, what will be the most important thing in the future? Of course, it is the issue that citizen engagement in all issues should grow in upcoming years, because the citizens are the king in the cities, and they need to be part of the developments. And thinking about that, we need to take the responsibility about the societal change. Innovative technologies can help on that. And therefore, the innovative technologies like a 5G are in the key role in the future. Of course, environmental footprint, or shall we say it, carbon footprint, or even carbon handprint. And what I'm meaning from the carbon handprint is that carbon footprint is looking the back, what kind of carbon influence we have in history. But if we are looking for the future, so that what kind of products and services and things are developed for the future, we are talking about carbon handprint. And this is the new concept that we have launched that here in Nordics by the Climate Leadership Coalition, which is a coalition where the cities, industry, and other associations are related. So it is extremely important that we are, if we are looking at the cities, the important are water, food, energy, and because those create lots of pressures for the environment. And human population is the other fact that actually in the last couple of years it has increased heavily, and therefore the planetary resources have been used up. So we actually, the cities, they need to work together to achieving the better lifestyles and for the citizens, and also for the technological and city solutions to be facing these societal challenges like reducing waste, reducing number of vehicles, and also having the sustainable public transportation systems. So the climate action is the issue where every city, regardless of its structure, regardless of the political representation, needs to act. And in the last couple of years, cities have started contributing to climate change targets heavily, and especially in EU, European cities have increased the greenness and spaces heavily in last years. And tech and the city are the issues that are actually it's required today. The technologies can be used to improve the quality of life and structure and environment. And this is the case also in these communication technologies and 5G, and should be, so that the application are the issue that actually we need to talk about it. And cities are actually more like innovation hubs, or should be like innovation hubs, so that the role of the cities has totally changed from bureaucratic role to the servant leadership role. And there the cities play an important role in innovation and identity and cultural heritage. And everybody will live in the cities, and capital cities especially have a heavy influence. So the citizen city is the requirement today, and so that actually city is for the citizens. And there as well, the innovation is an important factor. New ideas and solutions are created by the citizens if there is tools available. And of course, the resilience is an issue, especially now in Corona time, health as well. So it is important that the cities are actually for the citizens. So then how can then this 5G and technological solutions help the citizens? Of course, there's a huge connectivity need. We need the connectivity platforms, we need data platforms, and we need applications in the cities. And we need actually the similar kind of data platforms and similar kind of applications globally, so that we can connect as a citizens of certain city, also go to the other cities and have all the data and connectivity available. We call it also the neutral host operators. And neutral host operators, we mean the local operators, local and global operators that actually deal with the connectivity and data. We need the industry involvement. The power of the networks is important. Industry will make the solutions. Without industry solutions, we don't actually achieve the climate targets or other actually targets. It's extremely important to have the industry. I now talk a little bit more about these targets. And one of the big instruments in European cities is the Green Deal. And this European Commission came out last year with this Green Deal concept, which actually was targeting the Europe to be the world first climate neutral continent by 2050. So Europe wants to be the leader in the game. Of course, the Green New Deal is the concept that has been launched in America, and now America as well has put the climate to the key priority in the activities. And this contains, this Green Deal, a range of key political areas. And 5 policy areas are clean energy, sustainable industry, building and renovation, sustainable mobility, and biodiversity. These all 5 areas are requiring digital solutions, connectivity, and data. So actually we are in the main focus of the content today's lecture. Last year, the European Commission planned to put these 5 areas forward, and there was also the legislative initiatives that are actually developed in this year. I will actually a little bit discuss a couple of them. At first, the climate neutral Europe by 2050, which actually where there is a goal to reach the net zero greenhouse gas emissions by 2050. And this goal is shaped by the ambition for 2030 to cut the greenhouse gas emissions 50 to 55%. And this will mean that we need to strengthen the Green Seal diplomacy, also in international climate and biodiversity negotiation. Climate law is actually under talking, and also the European Climate Pact. The new strategy on adaptation on climate change has just actually, the draft has just 2021 came out from the European Commission, and there is a huge focus of ambassadors and covenant of mayors dealing with these cities together to act for the climate neutral cities. Cities are the most polluting areas, local areas, cities and regions, there are the most pollutions done. So therefore the act needs to be done in this local level. The Commission also aimed to renew every EU law and regulation, and of course that's actually a part of the negotiations. So I mean everything comes then to the member of the states discussions. There is a start to Renewable Energy Directive and Energy Efficient Directive as well, and these are important. There's lots of sectors in the smart energy sector to work together with the connectivity, 5G and other industries as well. There's a plan for the smart sector integration, bringing together the electricity, gas and heating sectors closer together in the one system. Circular economy is one of those targets, and a new Circular Economy Action Plan was launched last year. And there it is as such that there's, I mean, there's hope and promotion for carbon-intensive industries like steel, cement, and textiles, that they will focus the attention to the new circular economy plan as well, so that there will be clean steel making, clean cement making, clean textiles making, and so forth. Building renovation is one of the big issue, and energy efficiency, and this is the one target where there's lots of money dealt, and this renovation wave during this program period until 2027. Zero pollution is the target, that we have a pollution-free environment by 2050 in Europe. And ecosystems and diversity are the one area where there is strategy action plans in biodiversity, circular economy, zero pollutions, and so forth are done. Other dimensions, if I get it actually, the last part is the farm to fork strategy and transport. And let's actually, farm to fork is about the agriculture, green and healthy agriculture system. And that's actually coming also from the COP plans. Transport, in transport sector, of course the transport is the key sector where the pollutions are heavy. And there actually it is EU agreed that CO2 emission standards for cars needs to reduce, and the objective is to reach 95 grams CO2 per kilometer by this year. And the target is the zero by 2030. And there's also the plan for the more electric cars, so that everybody European can have the electric car, so that without having to worry about the next charging station or other issues. There's also the alternative plan for biofuels and hydrogen promoted in aviation, shipping and heavy duty transport, and also the cars. The very important initiative is that we leave no one behind, which means that there needs to have just transition mechanism to everybody, meaning that everybody could have equal opportunities for sustainable life, digital and sustainable life. And lots of R&D funding and innovations are provided by Horizon for these sectors. So this 100 billion euro budget for until 2027 is mostly about digital and missions, which are the moonshots. Moonshots and focus the environmental objectives, but also the other mission kind of the objectives. There's now 5 missions in Europe framed. There's climate adaptive cities, there's smart cities, oceans, cancer and soils. So these all are somehow related to sustainable green digital life. And of course, then there's a target for this diplomacy to support the Green Deal. So the Green Deal is the important factor in our life in digital environment. And industries. The key for the industries is to support these EU objectives in EU. And of course, in this industry sector, the issue is that we need to build trust, we need to work together and create the 5G digital solutions across various industries. And one of the key industries is this green sector, which goes for everywhere. We can take a closer look, but I don't think so that we have today time yet this one, but let's continue. And services for smart cities. And there are lots of services available for smart cities. And here are the couple of areas to mention: transport and mobility, smart emergency, and culture, public maintenance, and city monitoring. And here, actually, I want to take one initiative. When we talk about, the services, when we are talking about this data and 5G, the very important factor is the artificial intelligence. And I want to actually launch one report done by the European Commission, Vladimir Suha and Jean-Philippe Gammel, about artificial intelligence. And this is actually talking about humans and societies in the age of artificial intelligence. And it's not actually technological. There's lots of white papers done about artificial intelligence, but this document is looking more like other dimensions. And you can get actually this document from the chat in this lecture. There are 10 issues, 10 main takeovers in this report. The first one is, in the age of artificial intelligence, we all have different meanings about artificial intelligence. And that's extremely important. There is not such a one definition for artificial intelligence, and that causes certain problems. There is also the issues that we must not underestimate the cultural dimensions of artificial intelligence. What do I mean about the cultural dimensions? It means that artificial intelligence technology as such is sometimes capturing the cultures, but sometimes it's not capturing the cultures. Machines are coming. That's for sure, and machines already manage our emotions much better than we do. We are humans, so emotions are the issues which is not we can manage, but actually emotions and sense in sometimes, they are not going hand by hand. The fourth takeover is that good intentions will not prevent artificial intelligence from having extremely disruptive effects. Meaning there's different intentions in this life, and we need to be careful how actually the life will be governed. We talk a lot about the privacy, but how much we continue to give our data away. We give our data voluntarily in our social media, photos, pictures, everything. The takeover number 6 is freedom of choice is being eroded, and liberal democracy and free markets are at the risk. Number 7, we need to understand if and how the current mental health crisis is linked to the digital transformation. Eighth, creativity will no longer be a human prerogative or humans only possibility. Creativity machines are also creative. They can be even artists. Artificial intelligence risks creating the most unequal societies than ever existed. And what then number 10 is actually the most important. Education is our best bet. So education should be developed thinking about these different dimensions, not only the technological dimension. So in this era, we need to be talked about different dimensions in related to 5G, in related to data, in related to connectivity. Here it is actually the Fair Data Economy Rulebook, which was launched by the Sidra here in Finland, but actually that's global. And this rulebook for fair data economy is talking about that there's different questions that we need to think about in data, similar than in artificial intelligence. Business questions, technological questions, and data questions. And of course, these questions about a fair data economy are different in Europe, different in USA, and different in Asia. So we need to take different dimensions into account in our analysis of the issues. And if we are talking about the data businesses, we have data users, data suppliers, and then data facilitators. Data users are using only the data, but and they are companies. I mean, we are talking as well the companies as well as the individual. But if we are talking about companies, B2B, so the companies are engaged in answering the question, how can data be used to create value within our businesses? How data users can use the data either to inform business decisions or as an input into their products and services. So it is extremely important that we think about, the value of data. The similar issues are also the issues then if we are talking about data suppliers. Data suppliers, these are the companies that either generate data that it is intrinsic value and therefore marketable, or else serve a kind of a brokerage role by providing access to an aggregation of the data. So data suppliers are actually supplying the data. And then facilitators. There are some companies, they can facilitate so that they focus on supporting third parties and lacking the infrastructure expertise. So, they are just, being in the supply or facilitator role. So there are then differences in different companies, customers, and customer segments and value propositions between data businesses and communication businesses. But of course, this needs to go well hand in hand in the life of smart cities. But in this data businesses and communication businesses, in many cases there are also different parties producing the services. These two business areas are fundamentally different. The implication is such that how to then combine these offerings and how to then actually offer for the customers the relevant kind of the services, because in many cases you need the both. You need the connectivity and you need actually the data related services. So there is actually hard to realize the synergies between these two segments. But on the other hand, both data and communication businesses are platform-based, which means that a certain number of customers are needed to cover all costs related to these operations. This indicates that the geographical operation area of these kind of businesses needs to be large enough to sustain the required customer base. And of course, there's also, in that case, also the value for the customers, because then, I mean, if the customers are requiring, then also the services needs to be similar for all customers. But customers, meaning customers, companies, or citizens, in many cases are not requiring this, and that causes also the problems problems for the citizens, I'm meaning the users, because the solutions are different and even different in the logics. And of course, if thinking about those providers, in the provider's role, of course, they try to do as much business as possible, and therefore actually also selling the tailored kind of the solutions. Okay, then I want to actually to talk about what kind of analysis we need to do in this smart city environment. And I actually promote this kind of PESTEL kind of the framework, so that we look the different dimensions. And what I mean with these different dimensions, that we need to look in these cases, if we actually do the business cases, political, economical, social, technology, environmental, and legal aspects. And that's meaning that it's not only technological, that then in final end determine what kind of businesses will be scalable in the globe in the future. And these aspects may be different in different environments, different contexts, but there might be certain similarities, and those similarities then actually create the global business opportunities. Here, it is actually more detailed about these factors, political factors. What's mean about the political factors? This means about governmental kind of factors like policies, trade restrictions, tariffs, political stability, and so forth. And also the different kind of the infrastructure which is politically decided in the cities. Environmental factors, weather, climate change, we did discuss this one more. Economical factors, what kind of economic growth and financial support actually this can create. And then social factors, that what kind of cultures, health concerns, societal, environmental concerns, and also the emphasis on safety the issues have for the environment. So I want to actually to soon close my lecture, thinking about the cities environment and the Europe. It's extremely important to take the climate into account, and also the new EU legislation. In addition of this climate and Green Deal, there's also the new legislation done in Europe about personal data protection, and also in the GDPR data, which is the new European data protection rules. And that's important also, I mean, to know and take into account when starting the new businesses. We have a certain regulation on these issues. And network and competition and also the public procurement have certain issues. Public procurement is coming more and more important. Not only the legislation, but if we want to be innovative, and the requirement was that the future cities are smart and innovative, then also the public procurement needs to work on that basis. That means that also the innovations are brought early phases to the city environment. So thank you so much, and I will be available if you have any questions. Thank you so much.
And my name is, you already introduced me, Katina Kralevska. I'm an associate professor at the Department of Information Security and Communication Technology at the Norwegian University of Science and Technology. I will just, I have only one slide for our university that is part of the Nordic 5 Tech, where also Aalto University is a member of. And here is where actually this, where NTNU, it is located, in Trondheim, so in Norway. And those are the other members of the Nordic 5 Tech. So this is just information for the students. So since the students have, as far as I know, a diverse background, I will kind of like cover some, a bit the history of cellular networks, and then come to 5G and so forth. So first, basically, I would like to see, as we can see on this slide, almost every 10 years, there is a new generation of cellular networks that is proposed. And when I say cellular networks, so they are wireless, that means that the last link is wireless. So basically the connection that you receive, for instance, to your mobile phone, it is from the base station and it's wireless. And if we look through these different generations, we can see that we started with basic voice service that was analog, with analog-based protocols. Then we wanted to have more, such as sending text messages and MMS. After that, with 3G, actually, we started to have internet, so multimedia. And that was the first mobile broadband. While with 4G that we are using at the moment, it is LTE or LTE Advanced. We actually have even more throughput and even better mobile broadband. And now we are going with 5G, where it is not only about the throughput, but it offers many more other things. And we will see in this presentation what it offers. So if we look in this slide, we can say kind of like the need for speed has been the driver of these new generations of cellular networks. And it's not only the need for speed, it is also the need for a specific service. So we started with very simple service, like give me a call, then we moved to send me a photo, then video call. Now we want to have more kind of like extended reality meeting. And then hopefully with 6G and so forth, we will actually have even kind of like, we will be able to even send more senses and so on. So for instance, send me a hug. So the point is that there are many other new applications that are coming actually with the new generation of mobile networks. So if we just compare the key performance indicators of 5G compared to 4G, we can see that there is a significant increase in demand for data, more connected devices. Energy consumption should be lower because we'll have many more devices. The end-to-end latency should be very low because we want to have also many new use cases that are not possible to be supported with the current generation of mobile networks. Just want to say, I did not mention in the beginning, in case you have some questions or comments, feel free to put them in the chat now, and then later we can take them. So this is a comparison of the key performance indicators of 5G compared to 4G. So we can see that we need to do different changes in the network in order to enable and to be able to deliver this performance. So for instance, let's take the latency when we say it should be less than 5 milliseconds. Well, in some applications, it should be even 1 millisecond, such as, for instance, in an industrial scenario where the sensor should send data to an actuator, what this hand, for instance, robotic hand should perform. So the data should be processed very quickly and sent through the network. So we are talking the end-to-end latency that includes device processing. Then also we have the air interface. So the message is sent through the network, and we have in 2 directions, plus we have network processing. So, you know, it is kind of like we need to make changes in order to be able to do this type of things and to support them. So then maybe someone will say, why do we need actually all these key performance indicators? Like, why do we want to have such a huge high rates and high data rates and so on? Well, basically, the answer is, it is because we want to have many new other use cases. That is the driver of 5G and 6G and so forth. Because we don't want anymore this to be a network where we can call, and instead we want to open it also for the industry and so on. So it's kind of like also to have industry 4.0 and so forth. So if we look, if we try to map these different use cases or services that should be offered with the next generation of mobile networks, we can kind of like we can categorize them in three main categories. So enhanced mobile broadband, ultra reliable and low latency communication, and massive machine type communications. So these are the three main categories. And then of course, there are applications that fall in between some of these two and so on. And the key element here is that we want to have these different services. Actually, we want to provide them over the same network. We don't want to have a different network for each of them. Instead, they should be able to share the resources. So that's why we need something, we need to introduce new concepts that will enable this actually coexistence of different services that have significantly various requirements. Because, for instance, in ultra reliability and low latency, the latency should be very, very low. While here, maybe for massive machine type communication, the latency is not that important, but we want to support massive number of IoT devices, for instance. So it's kind of like we need to find techniques that will enable these different use cases to share the same network resources and to be able to perform and to deliver the requirements and to the customer that will pay for such a service. So kind of like I will, on the next slides, I just have kind of like to give you an idea what we want to have. It's like, yes, high resolution 3D data. We want to support huge venues and to provide reliable access to everybody there. People record, they stream and so on, so they should be able to do that. We already support, we have internet on the trains, but we want to have high-speed trains and to have continuous connection. Then virtual reality. Then, as I mentioned, ultra-reliable communication, where the latency is very important for remote surgeries, for instance, or autonomous vehicles that is coming as an application. So one way of dealing with this is basically also introducing the concept of cloud computing or edge computing. So you process the data closer to the end user so that you kind of like reduce the length that the information should travel. And with that, you reduce the time. So there are different things how you can do this. But basically, we want to enable all these different services that will enable us to have kind of like, if we put them together, it is what 5G wants to do for us is basically, we can see that we can include it in every aspect of our life and society in order to make it more sustainable, smarter, and to use the data that we have, and also to have much more innovation in terms of applications. So, as I mentioned, basically today we have this industry 4.0, and we are looking forward to many other new applications. And with 6G, for instance, we want to make them even smarter. That's why kind of like one of the key elements of 6G is including artificial intelligence. That is kind of like now even in 5G, there are many projects going on with artificial intelligence, but that will become even more and more important for 6G. And that will be kind of like one of the key concepts that are used there. So basically we want to have full-scale digital transformation of all vertical businesses. So that is why we need 5G. And now the question is how? How can we manage to have all of this in one network? So that's why we need some new technologies. And 5G is not just an incremental advance on 4G, what we can actually say for the other previous generations. Instead of 5G is actually, it is kind of like also brings new revolutionary and evolutionary technologies. And I will cover them in the next slides. So we can say that the radio access network, it is kind of like is evolving by integrating different radio access technologies, including this millimeter wave spectrum, because we want to have much more spectrum. So that is the way actually how we can enable to have such high data rates. Densification to have even smaller and more cells than massive MIMO, to have more antennas with beamforming and so on, so that you can kind of like aim for the specific user and so on. And I mentioned also cloud radio access network. So we kind of like bring the processing closer to the end user. There are also new technologies, what are also applicable actually in the radio access network. And they are network function virtualization, software-defined networking, and network slicing. And in the next slide, I will explain those three. So network function virtualization. So as I said, we want to have all these use cases in the same network. So how we should do that? Because at the moment, we have different elements in the network that provide specific function. So firewall, then we have message router and so on. But what we want to do, how we want to shift, is basically to have a generic hardware and to specify which functionality, what type of function it should be performed. So basically to implement it in a software, and we just want to run it on the top of this generic hardware. So basically we want to softwareize the networks. And network function virtualization in short, it decouples the network functions from the hardware so that they can run in the software. Or even kind of like to make it even more obvious to you, it's kind of like even now with our phone, for instance, with iPhone, instead of having, carrying camera, timer, and so on, we actually have our phone. And from the App Store, we can say, okay, I need this functionality, and I'm going to install it. So basically, and that is what we want to do it even with the networks. So we have the hardware that will be able to support these different softwares. And based on what functionality we need, we just go in this store and we choose it. So that is also the concept that the networks would like to implement. And there are many activities going on there. Another concept is software-defined networking. And software-defined networking, so what does that do? It kind of like even the name tells is it separates the control from these network elements into another entity that is called network, controller. So basically we move, as you see, these specific features from the different devices, we move them here. And again, we can kind of like with different protocols such as OpenFlow and so on, we can say, okay, through the controller that is in communication with these elements in the data plane, we actually say, okay, this is what I want to do, like this element, what should do with a specific flow, with a specific traffic that it will get. So basically, instead of having complicated plane, control plane software running on the device, so on each of these devices, we remove that and we put it here. We put it here in the controller that controls the functionality of these different elements. And we actually make these elements simplified, so that's simplified devices. So that is one of another concept that enables this softwareization and making the networks more programmable. So basically SDN and NFV, they complement each other. And what we want to do is we want to move away from vertically integrated, close, proprietary elements that enable very slow innovation. So we want to move from these specific devices in the network to more open ones where we have the hardware and then we define what this hardware we should use it for, and so on. So basically, we want to have open interfaces and to be able to develop different applications. And with that, actually, we open for more innovation and more players, because we don't need, at the moment, it's kind of like if we start buying equipment from Cisco and so on, then we should buy from them. They should also provide maintenance and so on. Instead, we want to kind of like be more independent. And also, this is a possibility to open for smaller players. Another concept that I mentioned, it was 5G network slicing. So the title actually can tell you what does this mean. I kind of like have it in this on this slide, so I move a bit. It's kind of like, you can say it, you slice the network. You slice the network into different slices that can have different, different tastes, let's say, like different profile. Why do we want this different profile? Because if you connect it to the use cases that I showed you, they have different requirements. So basically, we have this physical infrastructure. We have here all these network elements. And we want to say, okay, I want a slice for Internet of Things. And I want another slice for healthcare. And instead, and then you specify what are the requirements for that slice and which of those elements and the functionalities you are going to use. So it's not that you use all of them and so on. And that is actually, this is the concept, what I mentioned in the beginning, that these different slices or services should be provided over the same physical infrastructure. So we have the physical network, then we have the network slices that are logical networks running on the top of the physical network. And basically we want those slices to be isolated, because we don't want one of them to kind of like get information for the other one and so on, because it's at the end of the day, customers are paying and they want to make sure that there is no eavesdropping or whatever. So it's kind of like isolation is very important part in network slicing. So if we kind of like look more kind of like closely to this figure, we can see that in the networks, we usually have the radio access part, and then we have the transport, and we have the core part. So basically, those are like the multi-domain. So we want to have slicing in all these domains. Some use cases may just need, I don't know, a network slice that will go up to the RAN, in the access part. Some of them end-to-end slice, and so on. Then what does multi-tenancy mean? That we want to have different tenants that will pay and use this network, and we should be able to support them. And then this multi-RAD support, it basically we want to support different radio access technologies. And with the radio access technologies, we include also the ones from the previous generations and so on. Even Wi-Fi, we want to include it and so on. And all of this, why do we want to do it? Is because we want to provide a reliable connectivity. So these are some of the kind of let's say, characteristics of network slicing that are desired to have in 5G and so on. And now I will kind of talk more about the implementation of these features. So you kind of you saw what are the drivers of 5G, then the main concept. Now the question is, how are we going to implement those ones? And with network slicing, we create network slice instance. And that is basically, it has its own life cycle. So we define what we want to have, and network slice instance is basically, we say the requirements. That should be this is the amount of latency that we ask for, data rate, and so on. So for each service that we want to provide. So the customer specifies that is translated into network slice templates and so on. And then we should find also, the resources in the network. And then once we have that, we configure it and we activate the slice. Of course, we need to provide supervision and reporting to see that we actually follow this and we provide the requirements. We can perform some modifications. And then once the service is provided and there is no need at that moment, then we terminate the slice. So then, okay, so basically this is the life cycle. But how it is done actually, what is the entity that follows this life cycle? Well, that is the management and orchestrator entity, or MANO, that is called. So you have this NFV, you have the network function virtualization, then you have the software-defined networking, you have the network slicing, and now it comes another concept that is called orchestration. So you should be able to orchestrate these different functions, virtual network functions that are implemented in different parts of the architecture, so in the infrastructure that you have. And those things, they have to be orchestrated and managed. And that is done by this MANO entity that kind of instantiates, it tells, okay, these are the resources that we are going to use for these specific functions and so on, in order to activate the specific network slice instance. So this is more just to kind of you to know what are very important key parts of having that are driving 5G and so on. And what is very important is that actually 5G is not as closed as I said previously. We are more open for innovation. So that's why we have more open source. And also, of course, standards. We have the standards that define what should implement it and so on, but we also have open source players. What was not the case with 4G and previous generations. And that is basically, that brings us to the next slide, where I kind of map the different open source solutions to the architecture that I previously showed for the MANO entity. So here we can see, for instance, if we want to use for the radio access part, so this open air interface or an SRS-LT, they are one option of open source solution that we can use to implement the radio part. While for the core part, we can use the Next EPC, and also open air interface provides for the radio, for the core part. On the other hand, MANO, this is open button and so on, they are for implementing the orchestrator entity. And then we also have some here that are for SDN controllers and so on, like ONAP and so on. So they are different open source solutions for different parts that we want to include, different entities that we want to include in our network. And the ones that are highlighted in red, they are kind of like the most popular ones. So I will just briefly say something, for instance, for our implementation that we have it. So we have like cross-campus or cross-city actually implementation, where we have the radio access part in Trondheim, and then the core part in another city in Gjøvik in Norway. And basically we have cross-campus 5G testbed, where we use SRS LTE for in the radio access part, and we use open air interface for the core part. Those are the packets. While mCORD and mPower, they are controllers for the different parts of the network and so on. And they are connected by the transport network that is provided by Uninet. So I will just kind of like, for instance, if you want to set up your own small testbed, it's kind of like, what should you do? Of course, you need powerful hardware and so on. And I will here talk more about the software. So in every network, of course, you have these different elements, such as the home subscriber, a server, then the mobility management entity, then the control plane of the packet data network gateway, then the user plane, and then we have the involved node B. So we have, and this is basically connection to the internet, packet data network. So, and the interfaces that interconnect these different elements in the network architecture. So basically, you have to represent those ones in your testbed. And how you do this? So for instance, I'm going to show with the open air interface that has been developed by Eurocom in France. And there you basically, we have to connect, because this is basically how the architecture looks. But now we have to move one step forward, and we have to connect with those concepts that I already mentioned, that I explained. So we have to have these virtual network functions that represent these things. So, and then we also have to have the orchestrator that will be able to orchestrate the virtual network functions. So that's why, in order to have that, we introduce virtual network descriptors. So we have descriptors for each of the elements. So if you can see here we have so we take this one, it's much better. So we have here the virtual network function descriptor for the eNode B. And here we have this SRS LTE, since that is the software that we are using. And then here we have a VNF descriptor for the core, for the evolved packet core. And as you can see, for each of those elements that I showed you here in this slide, we have we represent them with virtual deployment units. So virtual deployment units that correspond to the virtual machine and containers that that they are implemented in. And after that, so basically this is in more details with the elements presented, but this one, it's basically this one. Then we want to connect them. So these two things, the RAN and the core network, they have to be connected in order to have network sliced instance. And then as we saw, the network sliced instance has its own life cycle that is orchestrated by the orchestrator and so on. So we connect them, these network slice sub instances. So that is what S stands here for. We connect them into one end-to-end network slice instance. So this is basically the procedure, the implementation procedure of one end-to-end slice, where you use this OpenAIRE interface and the SRS-LT. You introduce descriptors so that you know that you can basically orchestrate these elements, and then you connect them. And as an orchestrator, we use open source Mano that is supported by Telefonica and so on. So I will show in the next slide. And here, I don't log in now at the moment because I need to connect with and so on. And but here I have just a screenshot where basically the things that I already mentioned to you, where you have virtual network instances, where you define the packages, the network slice instances, and so on. You define them here. So you will define them, and you can see, for instance, a list of the network slice packages where you defined the different things that I showed in this slide. And that is the orchestrator that we are using, and it is widely used in the community. And here you can perform many different things. Once you have your testbed, you can do different experiments. So for instance, we try to use WireGuard instead of OpenVPN to enable VPN as a service. And what was the motivation for that one? Is because as I said, the demands for throughput and latency, they are becoming stricter and stricter. So that was the motivation why we wanted to implement and to compare WireGuard with OpenVPN. So basically you can look and check for new solutions. And if you want more information, I mean, I include also references, so you can always check them. And those things that I show here is actually connected to the previous slides that I showed. So if we kind of like summarize again, what do we want to have into one testbed, for instance? We want to have end support for end-to-end slicing. It doesn't necessarily mean that all slices should be end-to-end. We want to be able to support different radio access technologies. We want to also do it through the different domains. And we want to be able to support different use cases with different requirements. And in this, in the last slide, you have the references. For instance, in one of our papers, we give an overview of 21 small-scale testbeds, so not big ones, where you can actually test and use them for different purposes. So this is kind of like a good overview of what has been done so far. And some of them are open source. And I think that is actually really good if you put your source so that other people can download, and it kind of like, it helps a lot in the implementation phase. What I said in the beginning, also like a few slides ago, is that this OSM, the open source Mano, it is supported by very big players. So as you can see here, we have also a lot of industrial players such as Telenor, Telefonica, Bell, Verizon, and so on. So, and that is what I kind of like, we can connect it with the previous slide where I said that 5G, actually the intention of 5G is also to open for innovation. So we want to, it brings absolutely different players from different markets and so on, and also universities, so that actually we can use the potential in order to create better solutions for all of us. I also give a list of kind of like bigger bigger research projects that have their own implementations. But for these ones, you have much more, you need more finance and more resources in order to implement them. So that's why I would kind of like, I think it's more interesting to look in the small ones for the beginning, at least. So here it is also, it's a list of useful links where you can check more information. And the OSM community, it always organizes, I think last week, well, I think, yeah, it was last week, they have Hackfest and so on. So it's very big and it's open, where students can also register. And if you're interested in kind of like how you can use this, how you can use their orchestrator and so on for a specific purpose, then you can actually participate in this Hackfest. It is for free, and you can learn many things, and you can contribute to the community and so on. And here it is, those are links to the OpenAIRE interface and a few papers. And also there is a link to our GitHub where you can download our testbed. So with this one, I would actually close the presentation, and in case you have some questions, please feel free to ask me, or just send me an email. I kind of like I think it will be shared by the organizers. So thank you, and yeah, please write a comment or yeah.
Yes, thank you very much. This was such a great insight to the topic. Thank you very much. If there's any questions to Professor, we'd definitely want to receive them via chat, or you can open your mics as well at this point. But if there's no particular questions, I would like to say once again thank you. And we received some of the questions later on via email, and then we could possibly forward them to you later on as well.
Yes, of course. Thank you.
Okay. Thank you very much.
Thank you very much. Bye-bye.
Bye.